Okay guys, well, today we're going to be looking at a example with similar triangles. And these ones are a little bit tricky because there's a reverse triangle in there. So you just want to go through the process of how you do all of this and hopefully it makes sense. So the first thing is, if you don't have any labels like A, B, C, D on the triangle, you should do that. The first thing we have to do is prove that these are similar. So we'd say let the angle, because we don't have an angle here and I've just put these in. So let angle ADE be equal to beta. Right, and we know that theta plus alpha plus beta is equal to 180 degrees. And assuming we didn't actually have this angle down there, then that would mean that angle ABC would have to be equal to beta, as we have 180 degrees in a triangle. So therefore, triangles are similar as equal angles. Right, so that's sort of the process that we do. So what you generally have is you only get given the triangle, and you'd only be given basically that information there. So what we would do in this particular case to make this work, we would label that angle there, and that's similar to both triangles. Right, so we'd say theta is similar to both triangles. Basically, we've proved the two similar triangles. Now, the technique that we have to use to work out our value of x in here is we need to sort of work out these two triangles. Now, you can either use the table method, or you can use the two triangles drawn at different ratios. Alright, so we'll just do this method here, the table method, and we'll do the other method as well. Alright, so we've got triangle ABC, which is our big triangle. We've got our triangle ADE, which is our small triangle. So now we have to fill in the table. So we don't have anything for angle alpha, theta I should say. For alpha, we've had for our big triangle, looking across over here, we have x plus 5. Our beta is going to be x plus 3. For our small triangle, our alpha is going to be 3. And our beta, which would be this angle here, is going to be x. Now that's one technique of doing it, and you might like that. The other way is to draw the two triangles, big triangle, small triangle. You're labelling your angles, beta, alpha, theta. Right, and we know that this side over here, because I've drawn it in the orientation of the big one, that's going to be simply on this side here, x plus 5. That's going to be x plus 3. Right, when we're looking at this is the tricky bit, is getting at our angle alpha, theta over there, that's going to be 3. Beta on this side over here is going to be x. So it's in there, but it's just been flipped around. So now we've got our information. It's just a matter of now solving our triangle. So we put our unknown. So let's do x to 3 is the same as that's already over there. It's going to be x plus 3 to x plus 5. Now we're going to cross multiply. I'm going to bring that up there and that up over there. So that's going to be x plus 5 is equal to 3 lots of x plus 3. Right, so then that's going to give me simply x squared plus 5x. That's going to give me 3x plus 9. Right, so now I'm going to bring everything over the other side and simplify. So that's going to be x squared. 5x take 3x is going to give me plus 2x. And that's going to be take 9 equals 0. Now that's not going to easily factorise. So what I'm going to need to do there is either use the quadratic formula, or I could put into my calculator and press the button. If we did it using quadratic formula, okay, let's do the discriminant first. So discriminant's going to be equal to b squared minus 4ac. That will tell us if we've got a solution. So it's going to be 2 squared, take 4 times by 1 times by 9. So that's going to give me 4 take 36 equals minus 32. Because I just made this one up, actually, that's actually minus 9, isn't it? So that becomes plus 36. And so therefore that becomes equal to 40. Alright, so therefore now I can work out my x. Now my quadratic formula, x is equal to minus b, so that's going to be minus 2 plus or minus 40 all over 2a, which is 2. Now 40 is equal to 4 times by 10, which is going to be 2 root 10, so that's going to be equal to, so I might actually have to prove this is a surd. Alright, so if I had to do that, then I'd write this as simply minus 2 plus or minus 2 root 10 all over 2. Cancel the 2's out, so it's going to give me minus 1 plus or minus root 10. Now it can't be minus root 10, otherwise you're going to get a negative answer. So x is going to be equal to, when we're actually looking at our particular answer, x is going to be equal to negative 1 plus root 10, or negative 1 take root 10. Because it's a real value, you can't actually have that. So this is going to be our answer. You could work that out. Root 10 is about 3 point something, so it's going to be about 2.3. Alright, so it's sort of the process the same as what we've done in the previous examples. These are just a bit trickier, getting your labelled triangles and making sure you're not working back to front. Alright, so that's the process of working through those. Now when we come to the textbook, that's a little bit like example 4 in exercise 3a. When you're doing this one here, you're going to do something similar. You're going to label that side there, and then what you would have to do is you'd have to work out this angle here. That would be your beta angle, and that would be your beta angle. So that's a bit trickier, that one. Anyway, you need to work through exercise 3a, making sure that you can do any of those questions, and we'll work through some examples in class with you as well.